Thank you very much. Can you just confirm you can see my screen, can you, Chris?
Yes, I can see the screen, yeah.
Perfecto. In which case I'll turn my camera off after waving and saying hi to everybody, just to save a little bit of bandwidth. So, welcome to this presentation, Continuous Integration, with a subtitle of Taking Baby Steps Towards Automated Test and Release with LabVIEW and Test-TestStand, Part 1. Part 1, because we are barely going to scratch the surface here today. This is a new presentation for me, so I'm probably going to get the timings all wrong, and Chris is going to cut me off at the end, but that's fine. Feel free to do that. Fire a blow dart at me from the wings and take me out. So this is not intended to get you to the nirvana of continuous integration, and not even close, right? If that's something that you want to do, if you want to bypass these baby steps that I'm going to talk about today and get straight to that kind of that panacea, then there are others in this meeting, in the chat, that can help you out with that. My intention here today is to kind of pique your interest and to start a conversation. And I'd like to do that, especially in the test-stand community, where, let's be honest, many of us have struggled with test-stand deployments over the years, and where such conversation is pretty rare, to say the least. Hence a few of the jokes that are going on in the chat right now regarding test-stand deployment. That being said, this is a LabVIEW user group, so I'm going to ensure that the focus is around LabVIEW, and as such, my demos will be primarily LabVIEW based. So, quick introduction for those of you who don't know me. My name is Chris Roebuck. I'm a certified LabVIEW architect, certified test-stand architect, also incapable of using a mouse. I'm a software architect and director at Conrad Technologies, and I'm also the recipient of the world's coolest birthday cake, which is getting on for about 10 years old now, but I still love to flash it up every now and again. So, is this presentation for you? Do you work as part of a small team, all contributing to a single code base? Or are you a lone developer sat in your bedroom somewhere on the South Coast, desperately in need of a code reviewer? Are you looking to improve the quality of your software generally? Are you tired of finding untitled 1.vi committed to your Git repo? Would you like to carry on working on your source code while your exe, VI package, or source distribution builds are underway? Or do you like the fact that it gives you a great break to go and make a cup of tea, have a biscuit, see some daytime television? You want to just dip your toes into the water of continuous integration. And chances are you're not a Jenkins stroke Bamboo stroke DevOps guru yet. If you're saying no to any of those things, then sorry, this next 50 minutes is going to be pretty tiresome. So why are we doing all this? As I said, I think point 2 on that previous slide was, do you want to improve software quality? Now, this is a slide I've presented before, as a few of you will recognize, but this is one of the most valuable books that I've ever come across, and I think some of you will agree. So, Joel on Software is a book by a guy called Joel Spolsky, creator of Stack Overflow, which I'm sure many of you have used, creator of FogBugs, a bug tracking tool, but he also maintains a blog, joelonsoftware.com, which has some great anecdotes and short stories, a lot of which are focused on improving the quality of people's software. And he's very language agnostic as well, so you can apply a lot of his lessons and teachings to LabVIEW or to Test-Stand. And he asks a series of fundamental questions. Do you have a spec? Do you have testers or unit tests? Do you hold code reviews? Do you have a build system? Do you perform usability testing? And I've highlighted 2 of them in red, because 2 of them that we're going to talk about today and really cover are code reviews, or in this case, automated code reviews, and continuous integration, or a build system. So what is continuous integration? We may have heard that phrase thrown around at various NI Week presentations or when we've been browsing Slashdot, but what is it? Well, it's the practice of automating integration of code changes that we've made from one or more, I've said multiple, but it could be a single contributor into a single software project. So we've got code coming in from hopefully several developers into a single project. And we want to integrate those changes in an automated fashion. And we're going to use automated tools to assert the new code's correctness. So we're going to check that that code is actually good before we integrate it into our product. That might include functional testing or static code analysis. It might include building the software or some kind of build artifact, such as a package. It's often abbreviated to the term CI, and a lot of practitioners of CI, they refer to their workflow, their tool chain, as a pipeline. Okay, so let's just get familiar with some of the language to start with, right? If we're wanting to start a conversation, we want to make sure that we're using the right language to talk about these things. So just to recap, we're doing this why? Doing it to improve code quality. Our code will be functionally tested. Our code may be statically analyzed for things such as style, performance limitations, and dragons. I'm going to talk about the dragons a little bit later on. Reduce risk. We're going to start building our application. Realistically, we're going to build as soon as we're able to execute a piece of code, irrespective of whether we've implemented features that are on our requirements document from the customer. Chance would be a fine thing. And we're going to build very early, and we're going to build often. We're going to make sure that we've continually got a buildable product throughout our development process, or try to do that at least. Like Steen said, we're going to try and do the right things from the beginning. And reduce waiting time. In this case, with continuous integration, or the nirvana of continuous integration, should I say, our test and build operations become asynchronous to our development activities. So you might not get a chance for that cup of tea and that chocolate biscuit, I'm afraid. So what are the constituent parts of continuous integration? Typically, we've got one or more developers who are working on code that is ultimately going to be integrated into our project. They're making commits, checking in, to use another expression, checking in code into a source code control server. That could be something like Subversion. It could be something like Git. It might be Mercurial. It might be an older tool like Visual Source Safe. For those of you working in the defense industry might be familiar with that. And then within our system, we've got what is termed a continuous integration server, something that is able to fetch those changes that have been made to the source code and is able to test and then build whatever artifact, and then maybe even test again. If we've got an executable, we might actually want to do some automated UI testing, for example. But we're going to take that code, we're going to pull the latest or fetch the latest code that has been committed. We're going to test it. We're going to build some kind of output, might test it again, and ultimately we're going to generate a pass-fail result to say it passed the tests. It was able to be built successfully, and it's going to notify the team of that outcome. Hopefully it's not going to say Bob checked in some code, several VIs were called untitled 1, 2, 3, 4, 5, and half of them were broken. But it might. So where do we start in all of that? Because we've got 50 minutes left to talk about this, and as I said, it's part 1 of potentially 23. So where are we going to start? We're going to start with the test piece. We're going to start with the build piece and the determination of that pass-fail criteria and result. So in terms of test, today we're really going to talk about static code analysis and functional test, and we're going to talk about build. That might be a LabVIEW executable that we're going to build. It might be a test-stand source distribution or deployment image that we're going to build, or it might be a VI package that we're going to build. I'll try and keep an eye on the chat as well, Chris, but if anything critical comes up, do jump in and tell me. Thanks. So I'm going to talk about VI Analyzer. Now, I've got a note at the bottom that says, see my dedicated presentation about VI Analyzer, and there's a link to the YouTube video, and feel free to email me directly if you want the slides or the demos from that. But I've got an hour-long presentation about why we should be using VI Analyzer and how I was converted to the benefits of VI Analyzer, I guess getting on for about 8-10 years ago now. But suffice to say, there's a good presentation, hopefully it's good, about VI Analyzer where you can find out a lot more. I'm just going to skirt around the surface of it today. But VI Analyzer is performing static code analysis. It is analyzing a series, one or more target VIs, and looking at 3 elements. It's looking at their front panel, it's looking at their block diagram, it's looking at the properties of a VI. And it's checking for the following. It's checking for style issues, stylistic issues. It's checking for performance issues, and it's checking for those dragons, or things that I refer to as dangerous constructs. We talk in depth about that a lot more in that other presentation. So in terms of performance issues, I'll scoot through this really quickly. We're talking about identifying things such as using the value property of a control rather than writing to a local variable. There might be some performance implications of doing things like that. And I know these are silly, noddy little examples, but I just want to kind of make you aware. In terms of the bottom one, we're talking about things like building an array inside of a loop, starting with an initially empty array, and then effectively just concatenating elements. Obviously, that makes multiple calls to the Windows Memory Manager. We have to reallocate memory as the array grows in size. What we could do is we could pre-allocate an array of a particular size and then replace an element within that array rather than continually growing. And of course, once we get to 100 elements, we could pre-allocate again and increase the size of that array, reducing the number of times LabVIEW needs to call the memory manager. And in the top one, we've got some code that is making a calculation and then executing one or more cases, in this case, prepending a value to an array based on that calculation. That code can be massively simplified by using a conditional terminal, sorry, on the output on the loop boundary. So performance issues, just going through and identifying, yes, sure, the code runs. It does what we want it to do, but it could be more performant by making some changes to the code. VI Analyzer can help us with those things. It can help us with stylistic checking, such as using terminal view or icon view on our block diagram, or making sure that the front panel layout of our VI matches the connector pane, for example, making sure we've labeled long wires that run from one side of the block diagram to the other side of the block diagram, or checking class accessor names fall within a convention, or getting rid of the .lv class extension from class names so that our property nodes are nicely sized, as an example. And then those dragons, and I'm going to go through this, I'm just going to pick a couple of those. So those dragons that we talked about, dangerous constructs, things that might be bad in our code that are lurking there waiting to burn us in future, such as the use of current VI's path. We've all written code at some point during our LabVIEW career that has worked fantastic when we've been running it from source, and then we've fired up Application Builder, we've built that executable, we've hit the run button, and we've immediately got error 7, file not found, because we were silly and we used current VI's path in order to programmatically build a file path within our application. And of course, when we built it into an executable, the current VI's path changed as part of that build process, and that path is no longer valid. I'm sure that I can hold my hand up, we've all fallen for that one, I'm sure. And then write delimited spreadsheet. As another example, it contains a file dialog so that if we don't pass in a path into that sub-VR or into that function, it pops up a dialog. Imagine if you were doing that inside of a loop and you'd failed to pass in a path, we would have Windows pinging away at us, bing, 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 and popping up several dialogues, one after the other, and we click to try and get rid of them. We all know how annoying that can be. Or how about this, the file dialog ExpressVI? Yep, it's got 2 outputs: a Boolean to say whether it's cancelled, but if we cancel it, it also returns error 43. Which did we handle? Did we allow downstream code? Did we wire both? Did we allow downstream code to make use of that error out, or did we use the Boolean? So just examples of code that can kind of rear up and bite us. Maybe not today, maybe not when we're running on a Windows platform, or maybe not when as in the case of this one with the for loop, maybe not when our array contains elements, but when it is empty, then we lose our visa reference. So we might not find that immediately. We might only find that when our array is empty or when we've built our application. So these are what I refer to as dangerous constructs. VI Analyzer can help us with those things. We can also create a CFG. We can select what should be analyzed. We can select how it should be analyzed, i.e. which tests we're going to run. And we could include custom tests that we've created. Again, go back and have a look at that other presentation that I talk about. I tell you or explain how you can create your own VI Analyzer tests. Suffice to say, we can create different CFGs, different VI Analyzer configurations for different scenarios, such as when we're producing demo code, or just doing everyday checks that Bob isn't committing untitled1.vi to our repo. I'm sorry to keep picking on Bob, but it keeps committing untitled1.vi. We've got our pre-delivery inspection where we might want to check everything, because this code is going out to a customer and it's got to be squeaky clean. It's got to be perfect. I want to cross the T's, dot the I's, and make sure that it's perfect. We might need to concentrate on performance criteria or checking for potential performance limitations for a high performance application, such as a high throughput data logger. In that case, we might create a specific CFG to just focus on those things. And finally, cross-platform portability. If we know that our code might be executed on Linux or on macOS, then we might want to check that we haven't used things like ActiveX nodes or ActiveX functions within our code, because they're not going to work on a non-Windows platform. So we can create CFGs to test for those things. And when we're creating a CFG, we can tick which tests we really care about. Now, this isn't a VI Analyzer presentation, but I really wanted to get across that we can use this tool to improve our code quality. Now, when I presented this the first time a couple of years ago at NI Week, or presented the VI Analyzer presentation, one of the things that people talked about was, well, it's cumbersome, it's disruptive to my workflow. I can never remember to run it. So that's why we're talking about this today. We're talking about how can we automate these things? How can we make them part of our process and reduce that impact? Well, with VI Analyzer, we can create custom tests, and it's got an API. So that API allows us to specify an existing CFG, and or we could create a new CFG programmatically. But like I said, this is baby steps, this presentation today. So I'm going to suggest that we create a CFG using the VI Analyzer tool itself within LabVIEW. We choose which which tests we want to perform, and then we save that CFG. And then using the API, we can then choose which files we want to test. So we don't need to test everything. We can make a decision. We'll talk a little bit about how we can make that decision, which files to test, and we can choose how we want them tested. So we could have a variety of CFGs that are executed depending on the scenario, depending on the circumstance at the time. Are we just doing demo code? Are we about to ship out to a customer? Is it a daily build? Or do I want to check the code that Bob's about to commit because we know what he likes to call his VIs? So we get to choose which files to test and how to test them. So we can automate it. Here's a snippet of how simple this can really be. And again, we're talking baby steps. So we start with a CFG. Here I've got a file path input, which is a file path to my CFG that I've already configured to select which tests I want to perform. So I've used VI Analyzer and I've ticked the boxes. If I just go back a couple of slides, I've ticked the boxes of the tests that are important to me for that particular scenario, and I've hit the save button. And it saved me a file with a .cfg extension, which includes those particular tests. Now, using the API, I'm going to provide a path to that CFG. There might have been some files included as part of that analysis task. So the first thing I'm going to do is I'm going to remove those, and I'm going to add the items to the task that I want to ensure are tested. That's really just a belt and braces in case somebody saves a target file as part of that CFG. We can programmatically remove it and then add the files that we want to be tested to this VI analyzer task. And then it's dead simple. We then call this VI, which is on the palette when we've got VI analyzer installed, which we should have if we're running LabVIEW Professional or Full. And we can then run that VI analyzer task. It runs the tests for us, and it allows us to gather the results. So we get a cluster back out that shows us the results of that analysis. We can then parse that cluster to actually find out what it is that failed, if something indeed did fail. Okay. So that allows us to run the analyzer. So drawbacks. Well, it can be a bit slow, especially if we're testing a big project. If we've got lots of files and we're performing lots of tests, that could be slow. We might test already tested items. Again, I'm just wanting to provoke conversation rather than saying this is how you should do it. And we've got a question. When should I perform this activity? Do we do it nightly? Do I do it after writing new code? How can I reduce? I've said it could be slow. How can we reduce the workload of that VI analyzer task? Maybe we just run it when we've written some new code. So this is an idea. Again, I'm not saying this is the way that you should do it. I'm just trying to promote an idea, especially if you're new to continuous integration and you want to dip that toe in the water. One thing we could do is we could get a list of new or changed files from our source code control, because as Steen said earlier, we're doing that, right? We should be using source code control. We're going to do this thing properly. We could query our source code control system, get a list of new or changed files, and that could be the list of files that we then pass in to VI Analyzer and execute using its API. So in that example there, the list of files that I pass in could just be new files that have just been added or about to be added to source code control, or files that have the modification flag set on them in source code control, code that's changed. That would reduce the amount of VIs being tested and help with the slowness problem. And then we could make a decision. When we've run the tests, do we allow the commit to take place or not? Now, again, I'm targeting people that are making those baby steps and want to get into this mindset of testing code before. One of the things Joel Spolsky says, that guy mentioned earlier, in general, the longer you wait before fixing a bug, the costlier in time and money it is to fix. I have a little saying I tend to use quite a lot in this when I'm talking about this kind of thing. Bad code tends to stay committed. Once bad code has been committed, the incentive to go and fix it is far lower than before commit. If you can get the name of the VI to be something other than untitled one, if you can get rid of the default LabVIEW icon graphics and replace them with something meaningful, if you can make sure that that block diagram is tidy before it's committed, it will be far better. Once bad code has been committed, it tends to stay committed. Refactoring is an admirable goal, but I really don't see an awful lot of it in the real world, because once code's in the repo, it tends to be assumed to be good and ready to go, sadly. So this is an idea. You could check your code on each commit. Obviously, you want to run a very minimum set of tests, such as make sure the name is not untitled one and that the VI has an icon, but they're the things that Bob's struggling with right now, so I need him to start renaming his VIs correctly. So how do we find out what's changed? Well, we could query our source code control. I don't know if you're using Git, I don't know if you're using Subversion, but you could query the Git binary and say, get me the status of all of the files, and then just filter out the ones that are modified, filter out the ones that are new. If you're using Subversion, you can do the same thing. You can query Subversion. Or you could use, if you're using Tortoise SVN, it's even easier. You can use the API there and pull out a list of modified files. So we've got a list of things that have changed, and we can now pass that list into a very simple piece of LabVIEW code and run VI Analyzer. So what have we learned so far? We've learned that testing code using VI Analyzer leads to improved code quality. We've used that testing code using VI Analyzer helps us adhere to coding standards and rules within our department. And we've learned that it can be automated to run whenever we want using its API. And that might be when we make a commit. It might be at 11 o'clock in the evening. We can choose when we're going to run that piece of code that will analyze the VIs. We can optimize our time by running this out of hours or on a limited set of code files, such as those that have been modified. And we can retrieve a list of modified files from our source code control system. So therefore, we could build a simple application to run VI Analyzer on changed files at any given point in time or on occurrence of an event. Next, unit testing. What's unit testing? Well, Steen mentioned this. Again, it's one of these things that we should be doing, but this is baby steps. These are people, hopefully we've got people on this call that want to dip a toe in the water of these things and find out more and start to play around with them, and maybe aren't quite ready to jump into that nirvana situation just yet. Unit testing are narrow scoped functional testing or narrow scope functional testing of a particular method or algorithm within our code base. I am not advocating that you go and unit test every single VI in your project. Absolutely, far from it. But you might have algorithms, particular behaviors, functions, methods within libraries within your project that lend themselves very much to functional testing. And I'm going to give an example of one of those in a little while. We also have the concept of test-driven development. Now, there are people on this call that can talk at great length about test-driven development, so I'm not going to particularly, but what I'm going to talk about is that test-driven development advocates writing a failing test before we even write the code or implement the code for which that test was designed or for which that test was implemented to test. Okay, so we're going to write the test first. We've got a shell of a VI that maybe has inputs and outputs. We know what the function has available to it as an input. We know what its expected output is, but we haven't implemented the code yet. So we write a unit test and we check the various inputs and outputs to make sure that they are as expected. And of course, when we run it, there's no code. So of course the test will fail. But the idea is that then as we start to implement that code, more and more of our unit tests will start to pass until ultimately all of our unit tests pass, and hopefully we've got fully implemented code at that stage. We can check functionality of a code or algorithm that's been changed, or maybe at the beginning of a work session or at the end of a work session. If you're part of a team, it's quite nice to be able to say, okay, I finished making changes for the day, run the unit tests and know that everything still passes and that you're safe to hand over that project to another colleague. Or when you start in your work session, to be able to run the unit tests and say, yep, I'm starting from a position where the code works as expected. I now know I've set a baseline, and now I know that any changes that I make are being made to working code. I.e., if it stops working, it's my fault and I need to fix it.
Chris,
so,
just a
yes.
quick question in the chat from Kevin.
Yep.
Once you have the results from the analyzer, what does your workflow look like to fix those issues?
I'm kind of going to point you back, Kevin. I'm going to point you back to the other presentation. I mean, the workflow can be very much depending on when you've implemented the test. So, for example, let's say you've decided I'm going to run a particular CFG on essential tests, and I'm going to run it as part of my commit process. You might actually block the commit until that test passes. So the workflow is go fix the code, go change the name of that VI, give it an icon, whatever those essential fundamental tests are, you might choose to block a commit at that point. If it's a nightly build, maybe you produce a report and you don't progress until you fix those issues. And I think it's important to recognize I don't want to sound like a stuck record, but bad code tends to stay bad once it's been committed. So I think it's important to fix bugs, to fix issues that are flagged by the tests as quickly as possible, and to prioritize those. Part of the workflow might involve things like, I'd talk about this in the VI Analyzer presentation, adding a note. So when you fail a test, add a bookmark to the block diagram of the VI that failed the test so that your other developers can find that bug very quickly, or can find that failed item very, very quickly, and then can resolve it easily. So we are going to talk a little bit about that, so I'll come back to that other question in the chat. So, unit testing, really quick overview and introduction. The example I'm going to give here uses JKI VI Tester. Other unit testing tools are available. This is what I'm using for this particular demo, and tends to be what I use in day-to-day development. So JKI's VI Tester, free tool, available on the LabVIEW Tools Network. And what you do is you basically put wrapper code around the code under test, or code UT, code under test. JKI provides setup and teardown placeholders and a test class for passing data between them. So setup is where you would perform any actions that need to be done prior to testing your code under test. So it might be creating a file. If your code under test writes data to a file, as part of the setup, you might need to make sure that the file exists. Or if your code under test does the creation of a file, then your unit test setup should make sure that that file doesn't exist prior to executing your code, because you might be confused and think that your code is working when actually the file was already there. Teardown is responsible for putting the system back into a known state following completion of the test. You don't have to use setup and teardown. They may or may not be applicable for that particular code under test that you're testing, but it's nice to know that they're there, and that JKI have provided a test class to allow you to pass data between setup, the code under test, and the teardown. Also find it's very good for testing of classes and inheritance hierarchies. The test cases themselves are classes that are added to your project, and when invoked, VI Tester executes all test cases in your LabVIEW project. So this is an example of a VI, an algorithm, if you will, of something that I worked through with a set of students quite recently. And as part of the project that we were working on, they needed to generate a test frequency array. And we said, well, it might be that you already have the frequency array. Maybe we load it from a file or something like that. But it might be that we just specify a start frequency and a stop frequency and a number of frequency points. So there's a couple of different modes of operation here. There's different potential inputs, but ultimately the output is an array of frequencies. So it's an algorithm, if you will, and some of the unit tests that we might want to perform are things like, if we've provided a start and stop frequency and a number of points, then element 0 and element n of the output array should match the start and stop frequency inputs. We should also test that the number of frequency points matches the array size, or that if we provide a start frequency and the stop frequency is lower in frequency, or the number of points is 0, it should create an error. It should raise an error. So we can actually define the behavior that we expect from this function before we implement it. That's our test-driven development, right? So we've actually created some unit tests on the right that are going to be run against this particular function in order to test that it's been correctly implemented. Here's an example. In this case, I'm creating 100 points, and I'm checking that the first and the last. Sorry, I've got a start frequency of 1, a stop frequency of 100, and I'm checking that the first frequency in the output array and the last frequency in the output array match that start and stop frequency that was passed in on the input side. It's a very simple basic test, But this gives you an example of what a unit test, if you've never seen one before, gives you an example of what a unit test might look like. So we're providing inputs into our unit, our code under test, and we're checking the outputs and making sure it's good or as expected, and then passing that Boolean result to VI tester to return. We can run VI tester from the toolbar in the project, and we get a report and we get a nice graphical result. Yep, you've passed. Even better, going back to the subject of the presentation, it has an API. So once we've written those unit tests, we can simply use this one VI that JKI have put on the palette. We can point this VI to our LabVIEW project, and JKI's VI tester will execute all of the unit tests within our project and return the result and the details of those tests that were performed. Okay, so we can automate the testing of VI tester. Of course, other unit test tools are available. So what have we learned? We've learned that testing code using VI tester leads to improved quality. Developing code using VI tester helps to start down the path of test-driven development, and it can be automated to run wherever we want using its API. We can optimize our time by running this out of hours or on a limited set of code files, and we know how to retrieve a list of modified files from our source code control. Therefore, we could build a simple application to run VI tester on changed files or at a given point in time or occurrence of an event. Starting to see a theme developing here. So just to drop out of this for a second and show the API in action, here we've got an example of that. We're passing to a path or passing a path that contains some unit tests to that function, and we're grabbing the outcome and the details. Let's see if we've got that project open. Not that one. There we go. So we've got a very simple, as simple as we can get. I've got a unit under test, which is a VI that takes in an input and it doubles it. And I've written a unit test to check that the expected outcome is, or the outcome is as expected. So we can point it at that path. There I go. Bear with me 1 second. Bear with me. Sorry about that. Okay, so I've got pointed at my project. I can just run it, and there we go. It passed the unit test. It was a very simple unit test, but there I go, and I get the results of my unit test. Let's go and mess up the test so that it fails. Instead of doubling it, I'm going to multiply it by 3 and go back to my tester. And now when I run it, it fails because that function no longer doubles the output. So quick example, but you can see in terms of code, as long as I've written the unit tests and they're in my LabVIEW project, then I can automate the execution of those. Next part, release. So we talked about test, and now we're going to talk a little bit about build. So in LabVIEW, we use Application Builder to build our application into an EXE, so that it requires only the LabVIEW runtime engine to execute. Asterisk, I know it might need other libraries, other runtimes, vision, etc., etc. But the premise is we build our source code into an EXE that could run just using the runtime engine. It is defined by a build specification that we configure. Of course, Steam's shown some really cool tools earlier on today where we could maybe programmatically build some of those things, but we're taking baby steps here. So we might want to configure our build specification as part of our project. That build will fail if the code is broken, and it has an API. So the LabVIEW Application Builder has an API that allows us to programmatically run a build specification and produce some kind of build output, whether it be a source distribution, whether it be an installer, whether it be an exe, whatever it is. And it's pretty straightforward. We provide a build specification name. We provide a path to the project that contains that build specification. We provide a named target for our build and run that VI. So let's have a quick look at that. So let's get rid of this one for a second and this one. And here I've got a project. Too many VIs open here. So here I've got Automate App Builder. So I've got a path to a project, and I'm just going to go ahead. Not with that code, I'm not. I'm just going to go ahead and I'm going to come back to that demo in a second. Mistakenly copied the wrong one across. So I can run this against a build specification and automate my building of my exe. But it might not be an exe. It might not be a source distribution that I want to build. It might be a package. Again, Steen's kind of beat me to it. He's shown off some really cool tools and set the bar pretty high today. So it's kind of a follow that situation. But the thing that our build artifact, the output of our build might be a VI package or an NI package. Well, again, these tools have APIs that allow us to automate the building of those things. Caveat VIPM, you need the professional version in order to be able to access the API and automate some of these things. It might not be but you might not just want to use that API to build. You might want to use it to install dependencies prior to actually building an exe. So that API can be quite useful in other situations as well. So Application Builder can be automated to run wherever we want using its API. VI Package Manager can be automated to run whenever we want using its API. Again, therefore, we could build a simple application to build our application at a given point in time or on the occurrence of an event. So, what about Test-TestStand? I promised to talk a little bit about Test-TestStand. I don't want you feeling left out. Well, it turns out that Test-TestStand has an amazing tool that people don't really use, and it's an amazing tool that can be even more useful if you write your own tests. But it contains a tool called Sequence Analyzer, and it can be used for finding errors and dragons, and it can help you enforce your custom development guidelines, your rules that you have within your team about how you do development, about how your projects are laid out. It can also gather statistics. So Sequence Analyzer is a static code analysis tool. It can be run at edit time. It's available via Sequence Editor, but it can be run standalone. Comes with some built-in rules, similar to VI Analyzer, with boxes that we can tick and deselect or select rules, but it comes with a number of built-in rules. We can also build our own rules to test code the way we want, and we could use it for testing for dragons. So this is an example test that comes in quite useful in Test-TestStand, for those of you who have ever used Test-TestStand. An example here is that I've got some tests in Test-TestStand and I've forced them to pass. This might be quite useful during development where I'm wanting to check my report content, or I'm wanting to check some conditional flow, some conditional branching within my sequence. I might want to force a test to pass. I might have a broken DUT that actually it fails, it doesn't perform correctly, but I need to check the sequence as if that test is passing. So I could actually right click and say force to pass. That's great. However, what happens when we come to deploy? We do not want to be in a situation where we've left that setting in place. We want a sequence analyzer test to check for things like that and to say, hey, you're about to ship code and all these tests will pass no matter what. So we've got a potentially dangerous construct there in our sequence that we want to check for. Okay. So we can use Sequence Analyzer to do that. I should say as well, real world example, I have actually seen Sequence Analyzer deployed with settings set to force pass, and the customer thought everything was wonderful for about 2 weeks, shipping the highest quantity of product they ever had until somebody realized that the test was set to force pass. I bet that was an embarrassing conversation with a customer. So we can automate Sequence Analyzer. Sequence Analyzer, as I said, it's a standalone app. You can see the path there for my Test-TestStand 2020 installation, and we can pass arguments into that exe, such as the path to the Analyzer project and a target report path that we want. And Sequence Analyzer will go ahead and analyze our sequence, applying the rules that we've specified as part of our Analyzer project, and produce a nice little report at the end of it all. So let's see what that looks like in practice. So here I've got a path to an Analyzer project, a target report path. I'm going to go ahead and run it, and we'll see Sequence Analyzer spring to life, do its thing. It'll give us a return code telling us whether it passed or failed and some output, and then we can browse to a path on disk and have a look at the report that it created. So if I go ahead and browse that, we can now see it created this report a few seconds ago, and we can see the output. Yeah, that needs parsing, but we've got now a document that states what the outcome of our analyzed sequence was. I selected it to run all of the tests and all of the checks, so it's a fairly lengthy report, but we can do that, use that in our audit trail perhaps. So we can automate a Sequence Analyzer. We can also automate the deployment of a test-stand system. So if we've created a build specification in test-stand, be it a source deployment or an installer, we can then call the test-stand deployment utility, which is a standalone exe. We can call that exe with an argument and have it automate the deployment of our test-stand system. Again, we might want to programmatically build that build specification, some of the clever things that Steen was talking about. But right now, we're taking baby steps. Let's just get into the habit of automating that building of our test and deployment. And there's the code that we could use for doing that. And what I'll do is when I supply these slides to Chris, I'll also zip up and supply the demo code so that if those of you who've got test-stand, you can have a play around with that and see what it looks like yourselves. So what have we learned? We've learned that testing code using Sequence Analyzer leads to improved quality. Testing code using Sequence Analyzer helps us adhere to coding standards. It can be automated to run whenever we want. We can optimize our time by running it out of hours or on a limited set of sequence files, such as those that have been modified. And we know how to retrieve a list of modified files from our source code control. We could build a simple application to test and build our application at a given point in time or occurrence of an event. So now we're getting into the realms of what I would refer to as the little CI helper. We've now defined the following tasks for automation via their APIs. We're going to run VI Analyzer, we're going to run VI Tester or Unit Test Framework or whatever unit test tool we want to use. We're going to run Application Builder or VI Package Manager and build a package. We're going to run Sequence Analyzer and analyze our sequence, and we're going to run Test and Deployment Utility and produce that lovely test and source distribution. Each of those requires certain inputs and paths that we need to provide, but we could also supply some of those inputs, such as a list of changed files or files that we want to analyze, and we can retrieve those programmatically from our source code control provider. So we can put together all of those little code snippets that we've seen so far, and we could build an application. This is an example of one whereby we've got some LabVIEW options, some test-stand options, and some different tasks that we want to perform, such as running Sequence Analyzer or building a test-stand deployment, running VI Analyzer tests. We can choose which ones we want to do, provide the inputs we need, and actually go ahead and automate some of those things. So when do we do that? How do we do that? Well, it could be scenario-based. We just run essential VI Analyzer tests when we commit new code. We run everything and build it overnight. Maybe we schedule it using Windows Scheduler to just tick all the boxes, and at 11 o'clock, build it, run all of the tests. Maybe we just want to run to make sure that Bob hasn't called it Untitled 1 again every time he commits the code. Like I said, it's just an idea. I just want to promote some conversation about this. Somebody in the chat mentioned hook scripts. Absolutely. We could have a pre-commit script so that in Git, when we hit the commit button, we run some basic checks to make sure that it isn't called Untitled1, that it does have a non-default icon. Of course, we could do that on commit, on push. It could be client side, it could be server side. Because when we get into server side, we're really talking about part 2 of this presentation, or part 27 is probably more likely. So here's a video. It's also in the other presentation that I spoke to earlier, where I've got my Git client, and I've set up a pre-commit hook to say, okay, when I make a change to some code and try to commit it, I want to run all of my VI. I want to run some basic VI analyzer tests before I allow the commit to take place. So in this case, we should see I've got a modification now. I've changed a VI. I'm going to go ahead and commit and add a commit note to it. And when I hit the commit button, it's actually going to execute that pre-commit hook, run my VI analyzer tests, and probably fail them because I've deliberately put something bad in that code, and otherwise it would make a poor demonstration. So it's now failed my VI analyzer tests, and it actually opened. As part of my code, I got it to open and show me the VI analyzer test that it failed. I've made a change to the code now. I fixed it. I'm adding another comment. I'm going to go and do the commit. It's going to be retested, and this time the commit will succeed because the code didn't fail any of my VI analyzer tests. So starting to automate some of those things as part of our process. There goes our test. And hopefully this time our Git client accepts the code. There we go. You can watch this to your heart's content. So what's left? Well, we could trigger on new code arriving into source code control. We could grab the latest components from source code control in order to do our build. We could test on a dedicated build server. Let's talk about that next time. We've been talking for a long time. And like I said, there's other people in the chat that can help you with those kinds of things. You don't want to make the baby steps. If you want to just get that nirvana, that streamlined professional toolchain, there's people out there that can help you get that tomorrow. But if you want to play around with the test-stand deployment utility, if you want to play around with the sequence analyzer application and start to take those baby steps, then have a look at the demos that I'm going to ship with this with these slides, watch some of these videos again, and reach out if you've got any questions, and let's start that conversation. In terms of what continuous integration does look like, I've embedded this video. I'm not going to show it to everybody, but here's a video showing an Atlassian Bamboo build server automatically building a LabVIEW application running VI Analyzer. So you can kind of see, okay, maybe what could that nirvana look like? Where could I be if I put all these things in place? I'll let you look at that in your leisure. I'm not really going to look at that. So in summary, reviewing code increases quality. VI Analyzer, Sequence Analyzer can perform your code review and can perform it, I should have said, in an automated fashion, and can perform it when you make certain actions such as committing code. We've said testing code increases quality, so reviewing code increases quality, testing code increases quality. Build early. Start to implement your builds as soon as you possibly can. It's still great advice. Even better if that build happens automatically. Any questions? There's my email address if anybody wants to talk further about this afterwards. Otherwise, I'll turn it over and let's see if there's any questions. There's been a lot of activity I've seen out the corner of my eye. So if I've missed anything, Chris, that we need to talk about?
I don't think there were any questions that were missed. So there was a lot of comments and input, which was good. So no, I don't think there's anything missed, but like you say, open up the floor to anybody that has any questions.
Oh, somebody's pointed out that the link doesn't work. That's interesting.
I think yes, we sorted that out.
Ah,
for the video. Yeah, he sorted that out.
Perfect. I'll update the slide. Thanks for that.
Thanks very much for that, Chris. That was really good. Really good intro, and lots to think about and work on if people are on step 0. Yeah, all good stuff.
I think it's interesting to just, like I said, there's people and places where you can get the full solution. For me, especially with the test stand side of things, it was really interesting to start automating some of those things because let's be honest, even if we've been using test stand for a long time, test stand builds can be kind of painful. I know this is a LabVIEW user group, but some of us are test stand users. They can be kind of painful. And being able to automate some of those things once you've got a working recipe for good builds, I think that can really make your life a little bit easier and let you concentrate on some of those good practices that Steen talked about as well.
Yeah, absolutely. Yo's got a question. What's the output or result of the automated test stand deployment build?
Whatever your build specification is, Jörg, so you might have a test stand build specification that is and like I said, it's a baby step. You could programmatically build that test stand build specification. I'm suggesting that you'd actually use the test stand deployment utility to create a .tsd file and then run via the API, call the deployment utility, pass in the TSD file as an argument, and it could be an installer, it could be a source distribution where teststand does all of its funky relinking and collecting of dependencies and all of the great stuff that it does that remains a mystery to most people. So it could be a variety of different things. Great question. Is there a test stand user group? So there is indeed. There is a group that's run by Sri and maybe we can. Yeah, there we go. UK Tag. Yeah. So UK Tag. Those guys do tend to look at test. I mean, they're pretty general, but they do tend to like and look at test stand solutions quite favourably. So there's good material over there. But you're absolutely right. Yeah, the community is a little bit thin on the ground when it comes to test stand.
Kevin, I've just stuck the NI forum thing. Yeah, you got it. Cool.
Interesting. It's a nightmare. Yeah. Feel your pain.